Hi, welcome to my another session on C++, and today we are going to talk about pointer arithmetic, and we are going to explain it by using the arrays, which is basically a linear data structure which stores the homogeneous set of elements. I'm sure you must have studied it once, so let me quickly give you an idea about it. So basically, when we talk about the arithmetic with respect to the pointer, that means we are going to do an addition and subtraction operations on the arithmetic on the pointer variables. I'm sorry for that. On the pointer variables, we are going to do perform the addition and subtraction, and we'll see how we can move between the memory locations within a particular segment. So let's quickly get started, and let me open a VS Code for you guys. So here goes my VS Code. So as we know, the C++ skeleton code is going to be like this. So we write include IOStream using name space and std. So these things we generally do to have our C out and C in directly. Int main, and then return statement, which is going to be 0, and this is going to reflect to the particular operating system that my program has executed successfully. So let me just show you what exactly is the pointer arithmetic. Now there are two ways we can do the pointer arithmetic. So one way is as we have done in our previous video. So integer, let's say num equals to 5, and then integer, I'm going to declare a pointer variable ptr num equals to and%, that is address of num. So and% is basically address of operator. So as soon as we do this, so if I try to print out the value of address stored at ptr num memory location is going to be ptr num. So you directly write this ptr num, and it is going to be printing the value which is stored at the pointer num variable, which is basically pointer. So basically all the pointers store the memory address of some other location or variable or some reference. Then similarly, if I want to print the value which is being referenced by this particular ptr num pointer variable, so value referred or referenced by ptr num variable is going to be, and here we are going to use indirection or dereferencing operator ptr num, and that's done. So as soon as we are done with this, so let me just put up handle over here so that we can have the output printed on the next line. So once I execute this particular program, you can clearly see that the execution is going to print that address stored at the ptr num memory location is going to be 0x61ff08, whereas the value which is pointed by this particular memory address is 5. Now if you just wanted to have a assurance that yes, it is pointing to num variable only, in that particular case you can have a cout statement which is going to be printing the value stored at the num variable. Or I would say address of memory of num variable, right? So in this particular case, because and% is going to give us the address, so I'm going to write address of operator num and semicolon, and here again I'm going to put up and L. Okay, now if I execute this, so let me just clear the output so that you should get a clarity. So here you can see we have address of memory num variable is 0x61ff08. Then we have done the allocation of this address to the ptr num. Then you can see address stored at ptr num memory location is 0x61ff08. So this value and this value is matching, so this makes sure that our particular pointer variable is utilizing the reference address of the num variable. Now let's talk about how you can perform a particular arithmetic on this particular pointer variable values, right? So for this, I'm going to declare a particular integer array, let's say ARR, and I'm going to use 5 as its value. And after this, I'll just directly specify the values or initialize the values for this particular array, right? Now, if I want to print the values of this particular array, what I can do is I can just have the cout statement where value referenced or value at index. So as we are aware, the array basically starts from the 0 index. Here I can write starts from the 0 index. Value at index 0 of ARR. Here what I have to type is ARR. Within the square brackets, I'm going to put up a particular 0 index in the square brackets. So what is at the value of 0 index? So you can see 0 index, 1 index, 2 index, 3 and 4. So 0 index is going to display you 1 index displays you 2, and so on, right? So if I just execute this particular program for you once again, you can see the value at index 0 of array is 1. Now what I can do is I can just print 5 different cout statements, and I can simply write index 1, 2, 3 and 4, and I can just simply print all the values in the particular sequence. So if I execute this particular program again for you, at this particular point of time, you can see the value at index 0 is 1, index 1 is 2, index 2 is 3, index 3 is 5, index 3 is 4 and index 4 is 5. If I just wanted to change the sequence of these particular instructions, that is also possible for me. So if I want to have separate indexes to be printed on this particular program, in this particular case, you can see the sequence can be changed without any problem. How it is being done, because array the value stored in the array can be accessed by using the index. So right now you can see simple array index 0 is 1, index 3 is 4, index 4 is 5, index 1 is 2 and index 2 is 13. Just to make sure that we are accessing the right value, so I'm just prefixing 1 in front of all the values. So right now you can simply see the values have been changed. So we are using this particular array to print the values. Now the actual concept that how a particular pointer variable can be used to access the particular array index. So if I take on this particular part, so let's say because array is basically of integer type, so if I take integer streak ptr arr equals to arr, right? So if I use this particular arr, it is going to give me the address of the very first element of this particular complete array. So if I try to print the value of this particular address, which has been now stored at the ptr array variable, address stored at ptr arr memory location, so you can see it is going to print me the separate memory location, right? So if I try to print this particular value, you can clearly see the address which has been stored at the ptr array variable, which is a separate variable. It's going to have 0x61FE0, right? So it's the same index but a different offset for that particular segment. Now, just to make sure that we have the exact array, so let me do a cout, and I will just simply type in that address stored or address pointed by the ptr by the array variable to its first location is let me just type arr address. So as soon as I do this, and let me just do an endl over here. As soon as I do this, you can clearly see that my addresses are same. So that clearly indicates that whatever the array element index 0 address has been there, that has been pushed to the ARR. Now let me give you a particular magic. So see out value stored at the base address. So basically this is pointing the base address of ARR to PTR ARR variable. So the value stored at the base address of the array, instead of referring to the array, I will use a streak PTR ARR. Okay, so this is what is there, and I'll type handle. Okay, so now if I display you the value, what it is printing is 11. So that means the very first base address is 11, is basically storing the value 11. Now what if I do, as I mentioned, the arithmetic, right? So what if I do an addition plus 1 and then dereference the whole thing? When I do plus 1, the value of the address which is stored at the PTR array will be incremented by 1. That means whatever the next memory location which is being pointed by this particular pointer variable is going to be there. So if I take that particular concern in a sequence, that let's say the value which is stored at the base is 11, and when we increment it by 1, it will go to the next memory location and it should print us the value 12. So if you look at this particular part, okay, so let me just save it, execute it once more. So here you can see if I execute this particular thing, so as soon as I add the value 1 to the PTR ARR address value, it is going to increment and then dereference it. In that particular case, it is going to get me the memory location added. Whereas if instead of putting the parenthesis at the end, if I put this parenthesis before the addition operation, in that particular case you will find that it will do the what it will do is it will take the base address, dereference it, get the value, and then print the particular corresponding value dereferencing for the array variable, for the array base location. So instead of, for this particular part, I'm going to just add 3 over here. 11 plus 3 is going to be 14, and as soon as I do this, you can see it will give me a value 14. Okay, then if I make it 7 plus 11 is 18, you can see the value is going to be 18. So in this case, the value is the address is first dereferenced, the value stored at that particular memory address is going to be fetched, then it will be added to the whatever the value you are mentioning on the right hand side of the arithmetic operator. So this is what is the beauty of utilizing these parentheses at the right moment of time. So here I will put 1 again in the parentheses, so that means I'm referring to index 1. So here if you simply write that plus 0, right? So 0 is the index, 1 is the index, 2 is the index, 3 is the index, and so on. So if I take this particular instruction, make a copy of it, and then do 2, 3, and 4. So in this particular case, you will find 11, 12, 13, 14, 15 will be displayed on the screen in this particular context, right? And similarly, if I try to print the address, that is going to be displayed over here. So I can show you that also, where the address is, and we are going to put up a, instead of using the streak, I'm just only going to use the parenthesis. So I'll make a copy of this particular thing, 1, 2, 3, 4, and 5. So you can see first index, second index, third index, and fourth index. So if I execute this particular program for you, you can clearly see that 11 is stored at x 0x61 fe f0, then 0x61 fe f4, 0x61 fe f8, and so on. So as soon as I add the particular value to this particular base pointer, it is going to point to the next location. Now, how, if you look at this particular part, you can clearly see the difference between each memory location is 4. How it is possible? Because this is hexadecimal, so you can clearly see 0 to 4, 4 to 8, 8 to C, and C to 0. So why this happened? Because my integer here is of 4 bytes. So when you are adding 1 to a particular address, it automatically detects that its type is integer. So the next particular memory location, which is going to store the next value, is going to be after 4 bytes. So this is how this particular whole thing is being calculated, and this is how you can actually do a pointer arithmetic on the memory addresses which are stored or which are being referred by these particular pointer variables, right? So I hope this particular video must have given you a clarity on the concept that how you can actually utilize these particular pointer arithmetic for doing these kind of dynamic memory location accesses, and how you can make them versatile in your particular program. So thank you very much for watching, and if you like this particular video, please hit the thumb button, and please subscribe to our particular page and the particular channel. So thank you very much for watching. See you in the next video. Bye.